Hello, my name is Anthony, and today I'll be providing you with a short tutorial on how to use one of the new tools to WhiteboxTools, Generalize with Similarity. This tool is located within the LiDAR and Remote Sensing Toolset extension from Whitebox Geospatial and requires a software license to use. This tool can be used to generalize a raster containing class features by reassigning the identifier values of smaller features to those of neighboring features. Therefore, this tool performs a very similar operation to the Generalize classified raster tool. However, while the Generalize classified raster tool relabels small features based on their geometric properties of neighboring features, the Generalize with Similarity tool reassigns feature labels based on similarity with neighboring features. This tool considers that the idea of generalization can be extended if you use multispectral space and the distance between image objects in multispectral space to aid with the generalization process. Similarity is determined using a series of input similarity criteria raster, which may be factors used in the creation of the actual input class raster. This tool works by first identifying continuous groups of pixels in the input class raster through a clumping operation. The mean value is then calculated for each feature and each similarity input, which defines a multidimensional similarity center point associated with each feature. It should be noted that the similarity raster data are standardized prior to calculating these center point values. Lastly, the tool then reassigns the input label values of all features smaller than the user-specified minimum feature size to that of the neighboring feature with the shortest distance between similar center points. Before we actually get into running the tool, I just want to show you the data set that we're working with and then also the similarity images that we are working with. So as you can see here, this is a classified image that has been classified through using KNN. This is for a location in Ontario, Canada. And you can see I have an additional 7 similarity images that were used in the creation of this classified image. I'll just quickly turn those on for you to see. So these will be used as our similarity images when we go ahead and run the tool. So let's actually head over to Whitebox Runner and load the Generalize with Similarity tool. So in Whitebox Runner, you can find the tool by either searching for it or you can access it through the toolboxes. The Generalize with Similarity tool is located in the image processing tool in classification. Once you find the tool, click on it and the tool will load. The first input that it asks for is the input raster image. When you're inputting this, make sure you actually put the classified image and not the similarity images. So let's go ahead and put the KNN classified image. And next, it asks for the input similarity images. So let's go ahead and put those 1 through 7 clipped bands. Next, let's save the output raster as sim_output.tiff. And let's bump the minimum feature size to 10, just for round number's sake. Let's go ahead and run it. For your analysis, you may find that 10 is too large or maybe too small, so you can go ahead and put that to a number that is appropriate for your analysis. The tool executed in 6.8 seconds, so let's go ahead and view the output now. Let's actually load that output. Another interesting feature that I found in QGIS is you can copy the output of copy the color palette of one output to another palette. So let's actually copy the color palette that's on the KNN classified image. That could be done through accessing style, copy style, and then pasting the style. So then they have the same style and symbology. It's easier to compare the images. Let's actually just zoom in on a test area. Here's fine. So here's the raw classified image. You could see a lot of these small features that you ideally want to remove. And in the similarity classified output, a lot of those small features are removed. But let's say this is insufficient for your analysis and you actually wanted to remove a lot of these smaller features that you see here. You can go ahead and bump up the minimum feature size. So let's go ahead and let's bump that up to 30 and we'll change the output so it doesn't override. And let's go ahead and check that output out once it loads. That was created in 6.63 seconds. And now let's load the output, sorry. And once again, apply the same color palette to it. Paste style. So as you can see, a lot of these smaller features that were apparent in the classified raster with 10 minimum features have now been removed when you bump up the minimum feature to 30, which may be ideal for the type of analysis that you're completing. So it's important to just play around with those parameters. That concludes this tutorial. Thank you for watching this video. If you have any questions, feel free to comment down below. Thanks for watching.